Good afternoon to all. In this video, you are going to see about the orbital forming of the spur gear and helical gears. As forming of spur gear and helical gears. Both are similarly, but spur gear will be having a flat gears. Helical gears will be the same spur gear is a slantly cut is known as the helical gears. Now we see about it in detail. So orbital forming gears is also known as orbital forging also. A sophisticated metal working process used to create precise and highly quality gears, including spur and helical gears. This method involves controlled deformation of workpiece using a tool that follows an orbital path, typically producing components with the excellent mechanical properties and dimensional accuracy. This orbital forming process includes material preparation, heating, positioning, and orbital motion, cooling and removal. Finally comes for the finishing operations. In this process, the process for material preparation, the process starts with the selection of high quality of raw materials such as usually alloy steels, which are cut into appropriate sizes, billets to match the gear dimension. The billets are heated to a specific temperature to enhance their plasticity, making them easier to deform without cracking. Induction heating or furnace heating is commonly used. The heated billet is positioned in a die cavity designed to match the final gear shape. For spur gear and helical gears, the die cavities are precisely machined to include the gear tooth profiles. We see what is the orbital motion. A forming tool or punch is brought into contact with the billet. Unlike the traditional forging, where the tool applies direct pressure, orbital forming uses an orbital motion of the tool to gradually deform the material. The tool follows an elliptical path or circular path while applying the pressure, causing the material to flow into a die cavity and form the gear teeth. After the desired shape is achieved, the gear is cooled to solidify its structure. The gear is then removed from the die cavity. Additional machining as a grinding or heat treatment process may be applied to achieve the final dimension, surface finish, and mechanical properties. This ensures the gears meet the precise specification and perform the reliable in their intended applications. Now we see about the applications of the spur gear and the helical gears. So spur gears are characterized by straight teeth parallel to the gear axis itself. They are commonly used in applications where high load capacity and efficiency are required, such as automotive transmission, industrial machinery, and robotics. The advantages of the orbital forming of the spur gear is enhanced material properties due to the controlled grain flow during forming, high precision and repeatability in tooth profile and gear dimension, reduced material wastage compared to traditional machining method. Whereas the application of the helical gears. Helical gears have the angled teeth that form a helical around the gear axis, allowing a smooth allowing for smoother and quieter operation compared to the spur gears. They are widely used in high speed and high torque applications like automatic gearboxes, conveyors, and printing presses. The advantages of the helical gears in the orbital forming is improved mechanical strength and fatigue resistance due to continuous grain flow, precise control over the helical angle and tooth geometry, ensuring the optimal performance, enhanced surface finish, reducing the need for the extensive post processing. So advantages on this is the process refines the microstructure of the material, resulting in better mechanical properties such as strength, toughness, and fatigue resistance. Orbital forming achieves high precision and consistency in gear dimension and a tooth profile, crucial for gears that must mesh accurately, reduce material wastage, and compared to the traditional machining methods as process use the near net shaping techniques. We come to the end of the session. Thank you for watching the session.